I got the clicker. Just waiting for the slides. Hi. It was a great panel. Hard group to follow there. But I think the talk will be kind of on point for all the topics that were discussed. So I guess I can go ahead and start because I see my slides up there, so I'm going to. So hi, welcome to EDCON. My name is Jan. I'm a co-founder and technical lead at Zircuit. And Zircuit's a layer 2. We're a zero-knowledge rollup doing some special stuff, which I'll talk about a little bit later in the presentation itself. But really, this is a sort of very topical deck because you just heard people like Justin Drake in the last panel say a whole bunch of cool things about sequencers. There's a lot of innovation in this space. There's a lot of things sequencers are doing or claiming to be doing or wanting to be doing. And as we go forward, this will only sort of grow and evolve. The feature set will change. And so I'm going to talk to you about what some of those features could be, namely what you could see in the sequencer of tomorrow. So probably this would have been better before the panel, but here we are. Either way, I'll just start getting into it. So if you're here, you probably have heard of the concept of rollups. The last panel did introduce it. Rollups are layer 2 solutions, essentially trying to put a blockchain on a blockchain in some nice way that makes sense. And they've become incredibly popular these days. There's 30 or 40 or something like this in development. L2Beat, a website that tracks this, shows even more of that upcoming, including Zircuit. And as a result, there's a lot of competition in the space. There's a lot of things people are doing in different ways. There's a lot of ways these systems are trying to differentiate themselves. And while doing that, they're also trying to improve a lot of the features they have. One area where they can do this is in their sequencer. The general architecture of a rollup, is sort of the same everywhere. There's some changes in some places, but a sequencer is pretty common to every rollup out there. And as these rollups evolve and as these sequencers evolve, there's going to be new things added. And this talk will explore what those new things are and how we can expect a sequencer to look in the coming years and beyond. So, quick outline of the talk. We're just going to introduce the rollups and preliminaries of a sequencer, just in case you've been lost to this point. Then I'll talk about some of the really hot topics that are in this space that were actually talked upon in the last section, or last panel. So shared sequencers, base sequencers, some stuff that's new and unique to Zircuit, like sequencer level security, decentralized sequencers, and more. In short, this is a very active area of research, but I'll do my best to sort of give a highlight and educate at least some of the core features that you'll see in some rollups in the coming months. Before I do that, I should pause and make sure that we're all on the same page. While most of you, know what a rollup is if you've been in this space, if you haven't, I want to take a chance to give a quick intro to that. So rollups are a way of taking a blockchain, a layer 2 blockchain, that partially or totally derives state from an underlying blockchain like Ethereum. And so what you do is you have some system to generate layer 2 blocks, namely the rollup blocks, and you sort of take transactions from appropriate places. You build L2 blocks, you can see them on the top, and then you say, this is the state that I propose for the L2 block, or the L2 chain, and after some conditions are met, some finality mechanism is executed, everyone sort of agrees that the L2 is what everyone thinks it is. And to be a little bit more specific, you need something to generate blocks. This is called the sequencer. It can take transactions either from sort of the layer 2 network itself, so layer 2 transactions where they're cheap and fast, or they can take bridged assets from the layer 1 itself. So you could take Ethereum, or Ether rather, from Ethereum and put it onto a rollup, and you want to be able to use that. It has a representation. So sequencer is going to take transactions from 2 places. It's going to take all these transactions. It's going to do some of its sequencing, if you will, ordering. I'll talk about more on the next slide. Produce some layer 2 blocks. And then every once in a while, we're going to post some state roots from the layer 2 onto the layer 1. This will be done through some generalized component called a state proposer, where we say this is the state root of the layer 2. And then everyone needs to sort of agree that this is, in fact, the nice little state root for the entire chain. And so there's some finality mechanism that needs to come into it. You've probably heard optimistic rollups and zero-knowledge rollups. Those are the 2 popular finality mechanisms out there. Optimistic ones say, this is legitimate and good if no one challenges me on the output for the next, period of time, let's say 7 days. Or zero-knowledge proofs, zero-knowledge rollups use zero-knowledge validity proofs that say, actually this is the state root and it's final because I have a mathematical proof that there's no way I cheated in this block construction process. And both are really cool, but let's ignore all that because although there's very many interesting topics there, the sequencer is what I'm here to talk about today. So the sequencer, unsurprisingly, sequences transactions. It provides an ordering for layer 2 transactions. And it does this for transactions that come from either other layer 2 nodes, if they exist, like replicas of the sequencer, or from people signing transactions through wallets like MetaMask onto the layer 2, or from a deposit transaction that results or that originates on the layer 1 itself. So if you want to take assets from Ethereum to a layer 2, you need to do a deposit transaction, but more generally, we've also talked about sort of cross-chain calls coming through as deposit transactions. And then what it does is it tries to give two things. First, the layer 2 block. It looks and feels like a block that you're expecting on layer 1, usually faster, maybe more gas limits, different requirements there, but blocks that look and feel like blocks. And then it also writes the data of the blocks it's going to write in some way onto chain. In the past, before EIP4844, this was done through call data so that people could verify what was supposed to be in the blocks. Now, after EIP4844, most people are using KZG commitments, and that's also really cool. I won't talk about that itself. I'll talk about what's going on inside that box and where some of these arrows can change. So now that we're on a sequencer, now that we're on the same page for what a sequencer is, we can talk about some unique functions. One thing that's really cool, and it was talked about in the last panel, is shared sequencers. So what happens if you have two layer 2s being generated by sort of the same sequencing entity? This is maybe the concept of the superblock that was just mentioned on the previous panel, but essentially you can have a sequencer take responsibility for producing layer 2 blocks across multiple layer 2 chains. This is really nice for a couple of reasons. First, what you could do is very nice synchronous transactions between the chains on the shared sequencer. So on the super chain, for example, in principle, you could have very quick swaps between Base and Optimism or things like this. There's actually other benefits. You might get some nice MEV resistance because if things are cross-chain, it's a little harder. You have a little bit of better liveness guarantees. You certainly have shared infrastructure, which means the engineering overhead can also be a lot nicer for a lot of people. The downside is, you might get things like constrained sequencing. So as a layer 2, you sort of have to be on the same page, or at least have to talk to another actor when you want to change how your sequencing works. Nonetheless, it's a really cool, exciting idea. And it's actually related to the next topic, which is one that I think is really popular these days, this notion of base sequencing. So the idea of base sequencing is not mutually incompatible with the idea of a shared sequencer, but the idea is if you're generating an order, maybe you don't trust how the sequencer is doing it, or you just want to do it in a different way because you can, and you can use the layer 1 to actually provide an ordering for the sequencer. And you can do this through a couple of ways. I won't get into the details of how this works, but essentially you can have Ethereum itself do something so that the sequencer sort of committed or pre-confirming the ordering that comes out when it sort of updates its layer 2 blocks. This is really nice because it does give you a lot of liveness as long as layer 1 is online. You sort of know what the sequencer should be doing. Maybe the sequencer is down, but someone else could possibly pick up the node and run it very quickly because the ordering's already on L1, it's already known. They don't need to do a lot of the work. This has got some very nice economic things for Ethereum. Everything's sort of aligned with Ether and using the native assets there. That's really good. And you get some sovereignty too. The downside, again, possibly, you don't have MEV extraction. So if you're a sequencer, some chains maybe want to extract that value. Maybe, as a user, you don't want that, so it's not a negative. But certainly for some projects, it might be. And you also get some constrained sequencing because if you want to do something very fancy, maybe the L1, doesn't do that very efficiently. If there's randomness or something like this, I don't know. There's definitely options. But you can also do other things. So it's not just about sort of combining chains or decentralizing where the ordering comes from. You can add other features, and I think this is what's really cool. This is one of the unique things that Zircuit's doing. Zircuit pioneered this concept of sequencer level security. So we actually want to have the sequencer be a first-class entity and do something for the greater good of the ecosystem that we're building. As a layer 2, we were looking at all these other layer 2s and thought, well, we want to do something where we can add an additional level of security on top of the blockchain that you can't really do in a smart contract. Smart contract, you can put some require statements and be very careful with your engineering. But as we've seen time and time again, hacks and exploits still happen on these blockchains. So what we did was we invented a system where we can actually ask some sort of an oracle in the computer science sense, not a price oracle, but a sort of malicious oracle to say, is a transaction going to be good or bad? And if it's bad, we're going to put that transaction into quarantine. It's not going to hit the chain. And what this means is the sequencer is now taking an active role in the security of our ecosystem. And if you're a user or a dApp developer on Circuit, you get this level of security for free that you can't get anywhere else. So this is really, really nice. Now, the difficulty with doing this is that it's a first engineered thing, and we need to get some work to decentralize it and make all the other things work that are very nice. In principle, it's not incompatible with either shared sequencing or base sequencing, but it is going to take some time to get that rolled out. And so, we're starting centralized, but I think that's okay because we're providing a nice value to our ecosystem. Of course, though, we would love to go decentralized like most other blockchains out there. And one way we can do that, first, what is it? So to decentralize a sequencer is really just what it sounds like. You want to have anyone run a sequencer. So basically, you're sort of going closer to the original idea of Ethereum where anyone can run a node, and you sort of sounds like this should be easy to do and quick in the sense that if everything's just a fork of Geth anyways, why not do it? But it turns out, there might be some issues with this. In particular, to keep the system as performant, it needs to be, or unless you do something clever like make it based or something like this, in which case you can get all these goals and requirements engineered, but I think it is going to take some time. On the other hand, if you can do it, you get really nice security functionalities for if the chain is offline. In particular, strong liveness guarantees say that if the operator goes down, you just run your own node, you recover your own funds, and there's no issues. The downside, though, is, as I've said, the complexity is sort of non-trivial to overcome, especially if you want your system to be performant, or if you want to do something that is sort of unique to your chain, or if you're doing multiple chains or something like this. There's added complexity here. And of course, because it's a decentralized system, you need to make sure your whole sort of ecosystem and group is on the same page. So those are the big features, but there's actually more. I'm sort of going through this quite fast, but I'll talk about some other ones. So some things that we haven't talked about, and I think that would be really interesting, I think are things like MEV extraction or sort of giving yield back to users. This is something that comes up very often in informal discussions, but I haven't seen too many teams actually attempt to implement this or realize this in practice, and I'm not really sure why. It sort of seems like a natural fit. It would be kind of interesting to see if you could have a sequencer where the unique functionality isn't security per se, but something like MEV extraction where you get funds back to users. Now, maybe there's some dangers there that I'm not aware of, but I think actually it's the most natural thing to do given the popularity of DeFi and other things. What would also be very nice is some additional zero-knowledge stuff if it can be performant. So all of those features I've talked about on the sequencer can probably benefit from zero knowledge. Maybe the only one you don't need to worry about in this situation is a based sequencer because everything's on chain and you don't need to prove it. But otherwise, if you're trying to claim that you're doing something unique in your sequencer, especially something like MEV sort of protection or no MEV extraction, you might want to have a provably fair sequencer. You might want to say, look, I'm definitely not cheating, and I'll have a zero knowledge proof. That might be very difficult with performance issues. It might be easier to just do it in a based fashion, but I would bet there's a lot of really interesting questions and approaches if you try to answer this question without saying your sequencer's got to be based. Additionally, what I haven't talked about a lot either is integration with other chains or networks. So the idea of a shared sequencer definitely talks to multiple layer 2 blockchains and networks. It will sequence for many chains on it, creating these super blocks. But there's other networks you could consider talking to or talking from. So in particular, if you're a base sequencer, maybe you want to actually get an ordering from a different chain. I don't think it would still be called based in that sense, but maybe you could get it from somewhere else. Or where you're posting the data for these soft commitments or getting these pre-confirmations from. You change that. There are data availability layers out there now that have become relatively popular. A lot of them have sort of sprung up overnight in the last couple of, I don't know, years, months or years, something like this. And all of that has its own sort of special niches in terms of approaches to sequencing. So your sequencer can start to choose where data is posted, and maybe that will mean even cheaper costs for you. Maybe it'll change the trust assumptions. Maybe it won't. Maybe there's some clever ways around some of these things. And then finally, sort of one of the biggest things that I've been sort of talking about for years is this notion of security of the sequencer being offline. With base sequencing, it's actually a really nice approach because maybe you don't need to worry about this as much. But for everyone else out there, the idea that you should be able to have liveness of the layer 2 just as robust as layer 1 liveness is very important. So we would need some functional versions of forced inclusion and forced exit mechanisms. So these are ideas that if you have a layer 2 network, it should be operational just as often as the layer 1. And so that will mean somehow bypassing the sequencer to put transactions into layer 2 blocks, possibly generating them directly onto the L1 in some way, or being able to recover assets that are trapped within that layer 2 in the event that the sequencer is offline. And honestly, a lot of rollups are still leaving this as future work. If you look at the L2B site for rollup statuses, a lot of them are stage 0, which maybe is not where you have this type of complete functionality. So you end up needing a lot of stuff that needs to be done. Nonetheless, I think there's still a lot of research that can be done there and some interesting ideas, again, without just possibly taking the approach of going based. Maybe base solves all of it. Okay, so that's most of the talk. I've got just a couple of minutes. I will just wrap up. Essentially, the key takeaway here, if you don't remember anything else, is that sequencers are evolving. In the future, we're going to see sequencers differentiate themselves in very, very unique ways. In the past, the question has been optimistic or zero knowledge. I think in the future, the question will be, well, what does your sequencer do differently? And that might be shared, that might be based, that might be security, that might be something else entirely. But the point is, the research and development in this component should not be overlooked, and it should not be one that we disregard. And we have to take it very seriously for a bunch of reasons. There are, thankfully, a lot of teams working on this, Circuit included, where we are doing some really cool stuff, and everyone's doing some really cool stuff, and we're early still. Despite the large number of rollups out there, the unique features are still yet to come, and we're going to see more. I didn't talk about even things like different languages being sequenced or different support for entire ecosystems, but I think there's a lot. And what this will mean is that you won't see layer 2s as just scaling Ethereum. You won't see things that deal with just cheaper and faster transactions. You'll see extra value propositions or extra ideas for securing ecosystems or onboarding users, which I think this is very, very valuable. And so I don't think we should rush to necessarily shared sequencing or some other sort of popular idea just because those ideas come quick. There are other ways we can grow the ecosystem at the end of the day. That's what's important. And so the takeaway is sequencers are definitely going to differentiate themselves going forward. And if there's a feature in a rollup that you want to see, but you don't yet know what's out there, I bet it'll come soon. Or post on ETH Research or somewhere, or talk to me and talk about this idea. Maybe it's worth building. There's still a lot of space for other different rollups, and I think it's going to be really exciting to see how it goes. So that's mostly my talk. I'll end with the thank you. So thank you from Circuit. Thanks for having me here at EDCON. This was a great venue, and I appreciate it. And if you have questions, feel free to reach out and build and stake on Circuit. Thank you.